Welcome to solverfy.
Number one, we want to find the measure and degrees of arc AB. Since we have an inscribed angle that is opening up to that arc, the rule is that the measure of the angle is half of the measure of the intercepted arc. So if the angle is 65 degrees, that's going to be equal to half of the measure of arc AB. Multiply 2 to both sides, and the measure of arc AB will be equal to 65 times 2, or 130 degrees. In number 2, we want to find the measure of angle DBC. It would be equal to half of the measure of arc that it intercepts, which would be the measure of arc BD. And if part of the circle is 192 degrees, the measure of arc BD would be 360 minus 192, which is 168 degrees. So the measure of angle DBC would be half of 168 degrees. A half of 168 is 84. In number 3, at the point of tangency creates a right triangle. If the radius is 7.1, the full side would be 14.2, and we can use the Pythagorean theorem. C squared equals A squared plus B squared, where C is the hypotenuse, which would be 18 away from the right angle, equals x squared plus 14.2 squared. So we'll subtract 14.2 squared and then square root to get rid of the squared. The square root of 18.2 squared minus 14.2 squared I don't know why I said 18.2 squared. It's just 18. 18 squared minus 14.2 squared is about 11.06. Or 11.1 to the nearest tenth. When we have point X outside the circle that is tangent to the circle in two spots, those must be equal to each other. So 7x minus 29 is equal to 2x plus 16. Subtract 2x to both sides, and we have 5x minus 29 equals 16. Add 29 to both sides, and 5x equals 16 plus 29, where 16 plus 29 is 45. Then divide both sides by 5, and x is 9. But the question is, what is wx? Wx would be equal to 7x, where x is 9 minus 29. 7 times 9 minus 29 is 34.